So welcome everybody, I'm Attila Mészáros, and yes, I will talk about Kubernetes resource orchestration, and mainly from the perspective of Java Operator SDK and the Kubernetes Glue Operator, but also in general. So this is a Kubernetes conference, so I assume you already know what is a Kubernetes operator, at least in a nutshell. So basically, it's usually just a custom resource definition that you apply to the Kubernetes API, extend it, and you basically run a controller, which is basically a pod that watches these resources and reconcile your resources, what you manage from a controller. And what worth to note is, makes sense to explain it a little bit more in depth, that this is not really just Kubernetes resources. It's, nowadays, within controllers, you control both Kubernetes resources, which live in an API server, but also external resources, which maybe your cloud provider provides you. Think of projects like Crossplane, where you manage cloud provider like AWS resources from inside controllers, from a Kubernetes controller. And you can implement these controllers basically any language. There are now frameworks for most of major programming languages, mostly Java, Rust, and of course Go is the most popular one. So what is the problem we try to solve? When you implement the controller, you usually, these nice frameworks, you provide you some API. And these APIs are very generic. It's a generic programming language. The good thing about these that you have the full power of a generic programming language. But other side is not that good, because you have the full power of a generic programming language. And you can basically have to learn it, have the basic patterns and the caveats and all the aspects. And if you, for example, never heard of an informer, which is a building block of a controller, probably you don't understand that much in depth the eventual consistency happening in these controllers and how this needs to be handled correctly. So but basically, at the end, you fill in these two methods, up in Java and down in Go. And we, about 3.5 years ago, in Java Operator SDK, thought about how can we make this simpler for our users, and how can make a more generic abstraction on top of these base layers for the Kubernetes operators. And first of it shouldn't be too restrictive. It should handle the kind of generic use cases that you want to do. And it should be as simple as possible to use. And that is basically was the big question: what is the right abstraction for such resource management? And if you think about what's happening in these controllers at the end, it's basically just calling API. It's either Kubernetes API, other APIs, Amazon, Azure, whatnot. Basically, these APIs are always RESTful. So Kubernetes has an exceptionally nice RESTful API for managing resources. So we basically have a kind of find an abstraction just how to orchestrate these RESTful resource creations. But we already know such systems, right? It's at least two of these everybody used in this room, I'm pretty sure. From Terraform, Pulumi, AWS CloudFormation, AWS CDK, these are well-known tools with a well-known semantics and behavior. So why we just take these abstractions and adapt it to the controllers? And they are basically pretty simple, right? This is what Terraform, for example, does. So what are the building blocks in the system, and how these would look like in a high-level abstraction for the controllers? And I want to take a look on that and hopefully basically also understand better what is the basic patterns inside these controllers. And the first one is, what do you do when you define a resource in Terraform, for example? Basically, you say that I have a desired state, and I want to basically this happen. I want to reconcile the target world with this desired state. We usually just get the actual resource from the API. If it doesn't exist, you just create it. If it already exists, you compare it with the desired state. If it doesn't match, then you update the resource. So it's basically just we can abstract this away in a backbone of this basic logical cycle and do it again and again during the reconciliation. And it's again the CRUD operations and RESTful APIs help with that. If you ever heard a Terraform provider, it's probably, you know that very well. And just the input is just the desired state of these systems. So what else? There is multiplicity, so there is a dynamic number of resources sometimes. And you just say that I don't want with n number, maybe the input is a dynamic number of users to be created. Although this seems to be just on first glance a simple for loop, and actually it's not. For example, if you create these 4 users and you delete one of the 3, the desired state changes. But the system has to know there was a 4th user somehow created. So you know that there is some state probably involved this somehow already. And there is data sources, which when we are reading just data, not really reconciling, we just reading and having it as an input for other resources. So having this model, basically this workflow and all these 3 cases, we came up with a notion in Java Operator SDK called dependent resources. And this is the dream job of a Java developer, right? Is you can design some super cool Java class hierarchies to cover these and just have the desired state and call the reconcile method on that resource instance. And basically, this handles you in the background or the gritty details of these informers and label selectors and resources in a configurable way. And I mean, this is a still very simple menu, but just simplest example, having a desired map. But I assume that there is just, you can imagine there is a different interface with a list of these resources for multiplicity. And if you don't implement these marker interfaces, any of them, this is just a data source. It just reads the resource. If you delete the deleter interface, it never deletes the resource. So basically, you can mark it how to make the behavior of these classes. One note to take what is different here with Terraform and all other tools is that controllers doesn't read the resource when it starts to reconcile. They always use caches. So the point is that the huge amount of potentially hundreds of thousands of resources exist on these clusters that we have to reconcile that would not fly that much without having caching the actual state. And that is when the so-called informers and the generalized concept event sources came into place. We cache the resources always, we reconcile on top of these cached resources and trigger reconciliation of these resources when something changed only. So not on demand, basically, that you probably use most of these in the infrastructure as a code tools. But we usually have more resources. So we usually have a set of resources, and these might depend on each other. And so it basically ends up with a directed graph without cycles, so a DAG. And it kind of implies some kind of ordering, how we are reconciled. You know, also is probably from Terraform, there is an explicit and implicit depends on relation between resources. So do we need this in Kubernetes? Kubernetes, by definition, with this controller architecture, defines it in a way that you just apply resources, they will eventually reconcile. Maybe they are dependent on each other, but just let's fail until, and retry until everything is consistent and everything is up and running. On the other hand, it's not all the time true, even for Kubernetes, and we have external resources what we manage from controllers, so, and there we definitely need also ordering. So this is also, and of course there is an implication of parallelism, so you can see that after resource A is reconciled, we can parallel reconcile B and D, and basically the separate DAG we can parallel reconcile also. So that's also regarding execution of these DAGs and these resource trees or resource graphs. Basically, the difference is that it is async. While in Terraform, this is synchronous. So when you run Terraform, usually it takes a bunch of time when your whole script runs and it's there. So also we have conditional resources when we actually don't create the resources all the time. And so this is what we ended up with notion called Java Operator SDK workflows, where we have a list of these dependent resources which are dependent on each other. And I have these preconditions, and have this ordering and have the all kind of types, and then we can call them basically from the reconcile call this whole workflow. Okay, so what else? There is also state involved. In the state, basically, in Kubernetes, we address, we store resources in status. So this is it's a little bit harder problem than it seems at first, but we can just put it there and read it on the next reconciliation with some other utilities have to use there. So it's a little bit more complex than that. Okay, so let's take a look on some samples. This is a sample from Keycloak operator. Is a major operator for the infrastructure as a code tool in Keycloak, and basically you can see that it just defines these Kubernetes resources and then reconciles them. And maybe has some validation in the beginning and status update at the end, but then it's basically it. We have also Gerrit operator, which is a set of resources, and again, the whole reconciliation is just one line or 3 lines of code patching the status. And we have our sample, the web page, where in the web page you can just have this set of resources and deploy a static web page with a config map, deployment, and service, and basically serve a static web page from and just define it this way. So it gives a little bit nice structure to these operators, and you usually just in the reconcile method at the end you just patch the status. Okay, so but it's still Java, right? Not everybody writes this in Java. So can we make this language independent and dynamic? And so basically this is the cherry on the cake that we came up with a tool called Kubernetes Glue Operator, which is kind of a meta operator that you can define these workflows, these resources as a custom resource. And basically it orchestrates Kubernetes resources and defines controllers just by applying a custom resource. It has 2 flavors, the operator and the glue. When operator is just a real operator and glue is just a set of resources you want to reconcile. The project is in beta state, but we don't expect the API change too much. So how does it look like? Basically in practice, for this web page operator, what you have to do is just install this glue operator, apply this custom resource, the glue operator, say that I want to watch web page resources and create me for these child resources which are templated and basically reconciled by the operator. And then we have conditions like the only create ingress, only this is expose is equals to true in JavaScript. So basically you can define these operators with and the controller basically just applying a custom resource. Just to demonstrate the power of this, this is a simple operator that says that I have a read-only resource, we call it related resources here, and copy this secret to every namespace. The child resource, the parent is a namespace, so copies it to every namespace. You can imagine that you could filter it and do some other operations, but basically it does it for you, the background. Everything that every namespace you have this secret, and there is the other type of resource, the glue, which is not an operator. You just say that I want to apply these resources. So how is this different from a Helm chart or other tool? It basically supports this depends on relationship. It says that I want to apply this mutation webhook with mutate pods only if the endpoint for that mutation webhook, the pod, is already running. Otherwise, it would be a chicken egg problem with the mutation webhook. So you apply this resource, it will first reconcile the service, the deployment, and then it will basically, if those are ready, it will apply also the mutation webhook. So the whole point is that there is you can easily write controllers. We try to be also a kind of a Swiss Army knife of this resource management in runtime on Kubernetes. And yeah, so basically that's the idea. There are already similar projects. So we started incubating 1.5 years ago. Amazon also released very similar, basically, project called Amazon Kero, which does basically the same as the Kubernetes Glue Operator. It says that I have these resources. Basically, there is ordering implicit here too, and you define the schema of the CRD basically there, and there is some validation. So it has nice properties. It's missing the concept of the glue, and but has a huge community. So I really encourage you to take a look on the Amazon Kero. And there is also cross-plane composite resources, which does similar, and probably you know FluxCD. And FluxCD doesn't work with CRDs, but Helm releases are basically also managing these resources in runtime. It downloads the Helm chart, applies the values you provide in Helm releases, and so that also one is my favorite tools. And there is a part of Operator SDK called Helm Operators, where you can just take a Helm chart, map the Helm chart input values from a CRD, and basically build the operator and deploy it. So basically you can transfer or convert the Helm chart to a direct operator in Kubernetes. But hopefully these higher-level abstractions makes your life easier, and just something to take a look about. Yeah, that's what I wanted to talk about. I think I was quite quick and much quicker than I intended, but thank you very much. If you have any questions.
Thank you, and we have a question. How does cache invalidation made? How it is done in case of kube controllers?
Cache invalidation. There is no cache invalidation. So basically, the pattern works in a way that Kubernetes has an API with the WebSockets that you watch resources, and you always receive the newest version of the resource. And then you cache it. And if this connection is losing, you lost the connection, you are basically retries it again and gets the newest resources all the time. It's relatively complex with watermarks and listing and reconciling, but basically you have always eventual consistent cache, and it's always in the WebSockets. So it's always a push from the Kubernetes API server.
Thank you. We have a next question. You mentioned FluxCD. What about Argo CD versus FluxCD in your purpose?
I don't have experience with Argo CD. I heavily used FluxCD, but unfortunately, so FluxCD is I like because it's really simple. It's really simple, and the GitOps solution, but I don't have experience with Argo CD, unfortunately.